A very good morning to one and all. Myself, Professor Chetan Gupta, CSE Department, SIRT, the Sage Group, and today we are going to discuss about the subject that is Database Management System. The subject code is CS502, and the topic in today's lecture that we want to cover that is normalization. And in normalization, we will have to cover first normal form, second normal form, and third normal form. So start with the definition of normalization. Basically, normalization is a process of organizing the data in the database. Normalization is used to minimize the redundancy from a relation or set of relation. It is also used to eliminate the undesirable characteristics like insertion, deletion, and updation anomalies. Basically, normalization divides the large table into smaller tables and links them using relationship. The normalization or the normal form is used to reduce the redundancy from the database table. So that means basically normalization is what? It is a process in which we want to convert our relation into sub-relation. Means we decompose the table for the easy retrieval of the data. Basically, the main goal of relational database is to design a relation database without any redundancy and inconsistency. If we talk about what are the different forms of or what are the different types of normalization, so we have these 5 types of normalization. That is first NF, that is first normal form, then second NF, that is second normal form, then third normal form. After third normal form, there will be the another normal form, that is a BCNF, that is a Boyce Codd normal form, then fourth NF, that is a fourth normal form, and 5NF, that is means fifth normal form. Basically, in this structure, we want to give the definition of each normal form. That means in first normal form, basically first normal form based on the atomic value. Second normal form, basically it is related with fully functional dependency. Third normal form, it is related with no transitivity dependency. Then fourth on F is based on basically no multi-value dependency. And fifth NF, a relation is in fifth NF when it is already in fourth NF and not contain any joint dependency, and joining should be the lossless. So these are the 5 types of normalization, and we will start with first normal form. Basically, first normal form or in first normal form, a relation will be in first normal form if it is contain an atomic value. It states that an attribute of a table cannot hold multiple values. It must hold only single valued attribute. Basically, first normal form disallow the multi-valued attribute. Means we does not store multiple values in a same cell, or composite attribute or multi-valued attribute and their combinations. Means basically first normal form is based on atomic property. Means all the values should be atomic or single valued. For example, we have taken an example of employee table. Basically, in this table, we have 5 columns: employee name, employee ID, employee salary, then location, and phone number. Basically, it contains 3 rows: employee ID 1, 2, 3. The name is John, Smith, and Peter. It contains some salary, locations, and phone number. So here in the location table or location column, what we have seen that the John, whose employee ID were have one, have multiple location like Bhopal, Indore, or Pune. So this table is an unnormalized table because first normal form is a basic normal form, or it says that the value should be atomic. What we have seen that 3 locations are stored in a single cell. means this table does not follow the property of first normal form. It is an unnormalized table. So what we want to do, we will apply the conditions of first normal form if we want to convert this unnormalized table into first normal form. So we have multiple solutions to solve this problem. So we have go with the solution number one. So this is the solution number one. What we have did, we have break down the relation into two tables. There is one table that is an employee location table, and there is another table that is an employee table. Here I do not create the table. Basically that table contains four attributes. We have, this is the first table that we want to show, and the another table that is an employee name, then employee ID, then employee salary, and employee phone number. So we will create another table which will based on name, ID, salary, and phone number. And we have created one more table that is an employee underscore location, which contain two records or two columns, employee ID and location. So what we have did, we have seen that in the above example, the employee one having a 3 city. So what is the first solution that we will break down, or we will insert 3 row, because we know the this is employee ID is a primary key. So because primary key is a key which does not null, which cannot be duplicated. So in that case, we have to create a super key with the combination of both employee ID and location. So what we have seen that we have inserted a record that is an employee ID 1 with the location Bhopal. Then again, we have inserted another row that is again the employee ID 1 with the location of Indore. And again, we have take another same employee ID that is a 1 and a Pune location, and then the employee ID 2 and employee ID 3. So this is one of the solution to break down this location into 3 rows. By default, employee ID is a primary key, so we cannot insert that first employee ID in 3 rows. That's why we need to merge this employee ID with the location and make a combination of keys that is a super key. So we have created one solution that we break down this into 3 rows, Bhopal, Indore, and Pune, with the same employee ID. But in that case, employee ID cannot be duplicated because it is a primary key. That's why we have create a super key. Instead of using only one attribute as a primary key, we have created a super key along with employee ID and location. So this is one of the solution. There is another solution to convert this unnormalized table into the first normal form. That what we did, we again taking the solution number 2, what we did, we have break down this Bhopal, Indore, and Pune into the 3 rows, because as per the property of first normal form, the value should be atomic. So this value now will be atomic. Each cell stored only one values, Bhopal, Indore, Pune. By default, this employee ID is a primary key, so we cannot do this whenever we want to break down a single row into multiple rows, because this value is repeated. That's why in that solution also we need to take this attribute and this attribute, the combination of 2 attribute, that is a super key. It will work exactly like a primary key. But what we have seen in this solution, that your John, that is an employee name, and in employee salary, employee ID, and also in phone number, the record are duplicated. So there are a lot of data redundancy just because of this conversion of unnormalized table into the first normal form. But right now we are focusing to convert unnormalized table into the normalized table. So we have do this. This is one of the solutions. So first solution is this one. So in this solution, what is the main advantage? We have avoided some kind of redundancy. We will create another table. Here we have to create another table with the name, with the column name, that is name, ID, salary, and phone number. And we have take this employee ID and location into the another table. So, and if you do not want to take 2 tables, if you do not want to take breakdown relations, so this is the solution. But the problem is this solution, that your name, your salary, and phone number, by default, these all are record are duplicated. We have another solution, that is a third solution to solve the problem of this first normal form. What we have created, we have break down this location into 3 columns. location 1, location 2, and location 3. So here we have reduced some kind of data redundancy. What we have did, the employee name, employee ID, employee salary is as it is. Now the location of employee 1 is Bhopal, Indore, and Pune. So in location 1 we have inserted Bhopal, location 2 Indore, location 3 Pune, and the phone number. But the employee ID 2 and employee ID 3 have only single location. That's why it is inserted into the location 1 column. By default, the another location is not available. If there is any missing value or not known value, by default we will put null attribute. So the problem in this solution is that we have avoided the data redundancy, but by default this null record is inserted. So here we go with 3 solutions. In first normal form, we have go with this solution number 1. We have to go with this solution number 2, or either we have go to with solution number 3. Now, second normal form. Basically, a relation, as per definition, a relation should be in second normal form if it is already in first normal form. And what is the property of first normal form? It says that value should be atomic. So we have to first check that whether that table is in first normal form or not. If that table it is in first normal form, then we have to check with the second normal form. And what second normal form says to us? It says in the second normal form, all non-key attributes are fully functionally dependent on primary key. If we talk about the second normal form, so here we have a table that is employee project table, in which having a 6 column: employee number, project number, hours, employee name, project name, and project location. So as per the rule of second normal form says that all the attributes should be fully functionally dependent on primary key. So here we made 3 functional dependency. Here in this example, we have 2 attributes, that is an employee number and project number. These 2 attributes are, we can say that, a composite key or a super key, which can uniquely identify all the attributes of a relation, like employee name, project name, and project location. So here we made 3 functional dependency. We have made 3 functional dependency. This is our primary key, employee number and project number. With the help of employee number and project number, we can easily identify hours. So here we made 1 functional dependency, employee number, project number. With the help of this, we can easily identify under the values of hours column. So this is first functional dependency. Now we have made another functional dependency, that is with the help of employee number, with the help of only employee number, we can we identify employee name? Yes, we can easily identify employee name. This is a super key. But with the help of employee number, we can identify employee name. And this is the part of a primary key, that is a project number. So with the help of project number, we can easily identify project name and project location. But this hours is a kind of dependent variable, which dependent column, the values of hours must be identified with the help of both employee number and project number. We have made another functional dependency, that with the help of project number, can we identify project name and project location? Yes, we can identify. Now we have to check this. These are the 3 functional dependency. Now we have to check whether these functional dependency are correct, whether this table it is in second normal form. So second normal form is says that all the attribute is fully functional dependency. Fully functional dependency means if there is a single attribute, if there is a single key, we do not need to check the second normal form, because we cannot decompose this at these primary key. But here is a combination of 2 primary key. So if we remove this project number, can we identify hours with the help of employee number? Can we identify? No, we cannot identify hours only with the help of employee number. Or if we remove this employee number, so with the help of this project number, can we identify hours? No, we cannot identify, because hours is a kind of dependent column which dependent on both. So means if we remove one portion of a primary key, if the dependencies still exist, so we can say that it is is in that is not a fully functional dependent, because the second normal form property says that attribute should be fully functional dependency. That dependency must not hold. If there is a dependency hold, that is a partial functional dependency. So with the help of with the removing of this project number, or with the removing of this employee number, is the dependency hold? No, because ours is cannot identify only with the help of project number or only with the help of employee number. So this three functional dependency is okay. Now we have another functional dependency. We have made two more functional dependency in the same table, that is in employee number, project number. With the help of employee number, project number, we are trying to identify the project location. Okay, now do not focus on this cross right now. I'm just giving the example. And with the help of another functional dependency, again the employee number, project number, can we identify name? Yes, we can easily identify because this is a super key. But here we want to check that if we remove this employee number from this functional dependency, can we identify project number? Can we identify, project location with the help of project number? Yes, we can easily identify project location with the help of project number. Means there is a break of fully functional dependency. We can still identify, means in this functional dependency, if we remove this, the dependency is hold na. So that is not fully functional dependency. Another example, that with the help of employee number and project number, can we identify name? Yes, we can identify name. But if we remove this project number, can we identify employee name with the help of employee number? Yes, we can identify. Means this is also not a fully functional dependency. So means this relation, if we see second normal form. But if we see these two examples, so we cannot say that this relation is in second normal form. So here in note, I have mentioned that after removing employee number and project number, the dependencies still hold, because we can identify project location with the help of project number, employee name is with the help of employee number. So this is wrong. This is not an example of fully functional dependency. So after removing employee number and project number, the dependencies still hold. That's why it is not fully functional dependency. It is a partial functional dependency. So this relation is not in second normal form. So we need to convert this. So here what we have did in the previous example, employee number and project number and hours, we have made one table, that is the employee project relation one. We have made another table, that is a employee table with the help of employee number and employee name. So there is an employee number and employee name. And third table is a project number, project name and project location. So we have break down this table. Now if you want to check that if there is a single attribute, that is a primary key. So here we do not need to check the second normal form. By default, it is in second normal form. It is also in second normal form. But here in this example, ours is fully functional dependent on both the attribute. So we have converted our relation into the second normal form as per their properties. Now it is that is a third normal form. Third normal form says that a relation should be in third normal form if it is in second normal form and no prime attribute is transitivity dependent on primary key. Means there is no transitivity dependency. Third normal form work on there should be no transitivity dependency, or if there is a transitivity dependency, we need to follow these two rules. X, for example, we have made a functional dependency that X tends to A. So either X must be a super key or A must be a prime attribute. These two conditions meet. We have seen the example. Okay, here we have seen the example that we have employee department relation. In that relation, we have a number of attributes like employee name, ID, date of birth, address, department number, department name, and head. What we have seen, this employee ID is a primary key. So we have made two functional dependency. Employee ID. With the help of employee ID, we can easily identify employee name, employee address, employee date of birth, and a department number. We have made another functional dependency, that is with the help of department number, we can easily identify department name and department date. So there is a kind of transitivity dependency that exist, that with the help of employee number or employee ID, we can identify department number. With the help of department number, we can easily identify department head, and with the help of employee ID also, we can easily identify department head. So there is a transitivity dependency. So we need to remove this transitivity dependency, or if there is a transitivity dependency, so this is not a super key. As per this, if we want to hold the transitivity dependency, X must be a super key. So here X is not a super key, employee ID is not a super key, means it is not a combination of department number and employee number. So this relation does not meet the condition of third normal form. So what we have did, we have break down these functional dependency. On the basis of functional dependency, we have made three. With the help of employee ID, we can identify name, date of birth, address, and department number. And with the help of department number, we can easily identify department name and department head. So what we have did, we have break down a table into two tables. That is a table number 1 and table number 2. There is another concept of alternate key, with that with the help of department name, we can easily identify department head. It is a kind of a alternate key. So this is the example of third normal form. This is the conversion that we have this table in third normal form. If we want to convert, we want to remove the transitivity dependency. So we have made one table, that is a employee department relation 1, that is another relation employee department relation 2. What we have did, we have made this employee ID as a primary key in this table. What are the attributes that contain name, date of birth, address, and department number. And we have created the another table with the department number, department name, and a head. Right now, there is no transitivity dependency in both relation. Means after the decomposition, both relation follow the property of third normal form. There should be no transitivity dependency. So here in today's lecture, we have discussed about what is normalization, what are the 5 types of normalization, and we have studies about first normal form, second normal form, and third normal form. In our next lecture, we will discuss the remaining normal form, that is the BCNF, fourth NF, and fifth NF. Now, thank you. Thank you so much.